Finding the slope between 2 points without a graph. If you have these in your notebook, you should write them there. If not, you should use a separate piece of paper. Before I show you the formula for how you could find the slope between the point 2, 4 and 7, 10, think about how you would do this ordinarily. You would most likely graph the points 2, 4 and 7, 10, and then you would count the rise and the run. You would count that the rise is 1, 2, 3, 4, 5, 6, and that the run is 5. However, this gets a bit trickier when you're given points like this, 542 and 105.52, because to choose a scale that will work and be readable on this graph is not as straightforward. So instead, I need to think about how I could find the vertical change, or the rise. That's the distance between my 42 and my 52. And I need to think about how could I find the run, or the horizontal change. That's the distance between 105 and 5. You might already be thinking, oh, well, I know that the distance between 105 and 5 is 100, and the distance between 42 and 52 is 10. So we'd have 10 over 100, or 1/10. That's a great start, and we still would need to do some extra thinking to figure out if it's a positive slope or a negative slope. So we're going to learn a formula that will help you find the slope between 2 points without a graph every time. Slope is the constant rate of change, or the steepness of a line. We use the variable m to represent slope. The slope is the rise, which is our vertical change up and down, over the run, which is our horizontal change from left to right. As we saw in the previous slide, we could actually take the difference to find the distance between our two y coordinates to find our vertical change, or our rise. And we could take the difference to find the distance between our two x coordinates to find the horizontal change. When you're finding slope, it's especially important to remember that 0 over a number simplifies to 0, and that a number over 0 simplifies to undefined. Because if we don't have the graph to help us out, sometimes we might mix these up. When we find slope, we want to identify the two ordered pairs as x1, y1 and x2, y2. All this means is that on a graph, if you have 2 points on a line that you're using to find the slope, we're going to decide that one of those is going to be our first point, and one of those is going to be the second point. Since every line has an infinite number of points, it does not matter which point you choose as your first point and which you choose as your second, but we use these subscripts as labels. They do not affect the value of the numbers, and they should be written to the bottom right of the x and the y. Then we'll set up our equation using this skeleton. The parentheses will help us to make sure that we remember to find the difference with subtraction and that we don't mix up our signs. Then we'll solve for m, the slope. When we do this, we're really finding the difference between the y coordinates over the difference between the x coordinates and setting it as a ratio. This is the same thing as rise over run, just without a graph. Now let's do some examples. Hopefully these match the examples in your notes, and if not, you can use separate paper to write them down. A, find the slope of the line that passes through 8, -3 and 2, -6. I know that my formula is m, or the slope, is y2 minus y1 over x2 minus x1. So the first thing I'll do is I'll write down the formula, and over time, you will memorize this and won't need to write it out. Then I'll label my points. I know that I have x and y in each point, and I'm going to call my first point, point 1, and my second point, point 2. Then I'll set up my skeleton where I have one value minus another value over one value minus another value, and I'll fill these in. So I have my y2 minus my y1, so I have -6 minus -3 over my x2 minus my x1, so I have 2 minus 8. Keep in mind that when we see a double negative, we're going to change that to a positive, which means that my slope is -3 over -6, which simplifies to 1/2. One thing that I like about using the formula to find the slope is that we're less likely to make mistakes with signs, whereas on a graph, we might forget to put the negative or to mark something as positive. If I wanted to sketch this graph, I'd have 8, -3, and I'd have 2, -6. And so I could see that the slope is going to be positive and that both points are in quadrant 4. Let's try example B. we have to find the slope of the line that contains these points. So again, I'll start by setting up my formula, m equals y2 minus y1 over x2 minus x1. And I'll label my points xy, xy. My first point is x1, y1, and my second point is x2, y2. It doesn't matter if you consider this your first point and this your second point, or the other way around, as long as you go in the same order and you're consistent each time. Well, if we refer back to a graph, we see that we can arbitrarily choose which is our first point and our second point, but we'll still simplify to the same slope. So now we want to set up our skeleton and fill in our numbers. Remember that you're always finding a distance, and so we're finding the difference. That's why there's subtraction. So I have negative 16 over negative 14, and negative 10, and negative 7. So I have negative 16 minus negative 14. That's going to change to a plus. And I have negative 10 minus negative 7. That's also going to change to a plus. So when I simplify negative 16 plus 14, I have negative 2. And when I simplify negative 10 plus 7, I get negative 3. Therefore, my slope is 2 over 3, another positive slope. You might be wondering, what if I swapped the order, like I've been talking about? Well, if I made this my second point and this my first point, I would still get the same answer, because it would still simplify down to 2 over 3. So it does not matter, again, which you choose as your first x and y and which you choose as your second x and y, as long as you maintain the same order of which number comes first. If you want, you could pause the video and try setting up C and D on your own. If not, you can keep watching and write as I write. So I've labeled my points and I've set up my skeleton. If you haven't done so, pause the video now. Now I'll fill in my values. So I have 3 minus 3 in my numerator, and I have 9 minus 5 in my denominator. I find these arrows helpful, and you might want to do that as well. When I simplify this, I get 0 over 4, which simplifies to 0. We would not leave it as 0 over 4. This is not simplified. Now, when I get a slope of 0, I should immediately picture this graph. Since I have the same y-coordinate in both of my ordered pairs, that tells me that I will be going up 3 from the x-axis in more than one spot, and therefore I have a horizontal line. We know this from what we've learned before, and it's always good to check that you have 2 points with the same y-coordinate, so you have a horizontal line if your slope is 0. I would suggest that right now you pause the video and you set up D, and then you unpause it and see if you are correct. When I fill in my formula, I have negative 6 minus 1, and I have 5 minus 5 in my denominator. That means that my slope is negative 7 over 0, or undefined. Just like we saw in the previous problem, if you leave it as negative 7 over 0, this is not simplified and is not correct. In fact, you might find that sometimes you have a different number over 0 than somebody else, but you should both get the slope of undefined. This tells us that we have a vertical line. And if we have a vertical line, we know that we must have had the same x-coordinate, because it means that we've moved over the same number of units, in this case 1, 2, 3, 4, 5. So we have 5, 1, and we have 5, negative 6. That helps us form a vertical line here. So we can double check that we should have in fact gotten a slope that was undefined. Using this formula can be really helpful, especially if you have graphs with different scales. So we saw this graph the other day, and we marked 2 points, and we counted the rise over the run. But I noticed that some people forgot to check that the scale was 2 on the x-axis and 3 on the y-axis. Similarly, I noticed that not everybody remembered to include a negative sign. You're less likely to make either of these 2 mistakes if you check your work or find the slope using 2 ordered pairs. So the 2 points that I marked are 0, 30 and 2, 27. I can use the formula, and I'll end up writing m equals 27 minus 30 over 2 minus 0 to get a slope of negative 3 over 2. It's the same slope that we got, again, the other day. However, This is a way or a different method that you can use in order to help avoid forgetting about the sign or the scale. If you've already hit brain overload, then I would stop here for today. But if not, then I would suggest that you at least watch this part of the video, because it will help remind you of, first of all, how to add and subtract fractions without common denominators, and second, how to simplify a complex fraction. So when I see this problem, these are ordered pairs that have fractions in them, but I'm going to set up the problem in the same exact way as I would if they didn't have fractions. So I have that my slope is my y2 minus my y1 over my x2 minus my x1. And again, I use the arrows to remind me that I'm going in the same direction both times. Now I have two subtraction problems. I have a subtraction problem in the numerator, and I have a subtraction problem in the denominator. I do not need a common denominator across all four of those, but I do need a common denominator for my terms in my numerator, and I need one for my terms in my denominator. So when I see that I have halves and eighths, I'm going to choose a common denominator of eighths in my numerator. And when I see that I have thirds and halves, I'm going to choose a common denominator of sixths in my denominator. If you don't remember how to convert from halves to eighths, I would recommend that you ask your teacher for some extra help. However, you might pick it up just from this. So since we're going from halves to eighths, in my denominator I did times 4, I would need to do times 4 to my numerator as well. And I can leave my 5/8 next to it. So I have 12/8 minus 5/8 gives me 7/8. In my denominator, I'm going from thirds to sixths, so I would do 3 times 2 to get to 6, and therefore I need to also multiply my numerator by the same number, or 2, to get 4/6. I see a double negative here, which changes to a plus, and 1/2 is the same thing as 3/6, so therefore my denominator is 7/6. I can rewrite this problem as 7/8 divided by 7/6, which means that this is the same thing as 7/8 times the reciprocal, or 6/7. Some people remember this by the quick memory tool, keep, change, flip. We keep the first fraction, we change division to multiplication, and we flip, or take the reciprocal of, the second fraction. I can cross cancel my 7s, and I get 6/8, which simplifies to 3/4. Therefore, the slope of the line between the two given points, right here and right here, is 3/4. As a quick side note, once we get to this fraction, we can also multiply by a form of 1, and in this case, my form of 1 I would choose is 24/24. Multiplying by 1 does not change a value. However, using this form of 1 will allow me to cross-cancel in both the numerator and the denominator, and so I would get that my fraction simplifies to 21/28, which is also 3/4. This is particularly a helpful strategy when dealing with decimals. Thank you for watching.